Hello students, welcome to the first screencast of the new school year. Like all screencasts after this one, they will occur on Thursdays, and they're quite simple really. I present to you a real-world problem having to do with what we are learning in class, in this case radical expressions. I will present to you the first problem, I will explain it in detail, I will solve it in detail. You will listen carefully, ideally, and then at the end, I present to you another problem similar to the one that I just explained, and I ask you to give the solution. More on that at the end. But first, let's begin. Last year we talked a lot about geometry, in fact. If you look at your screen, you're noticing a box. It's got height, width, length, all those things. And we remember last year we studied that height times width times the length gives you the volume of a particular shape, in this case the rectangular prism. But you know what you can also measure? You can measure something called surface area. Now we know what area is. Area is the space inside something of a two-dimensional object. Volume is the space inside a three-dimensional object. But if you're calculating something called surface area, the name implies it all. You are literally calculating the area of just the surfaces of whatever object you're talking about. In this case, a box, okay, called a rectangular prism, to get technical. It has, of course, 6 sides. 4 around it, 2 on top. Now, let's say you were to just take one of those sides, say the top side, the one that you can see right up at top, and you just wanted the area of just the top. Well, then you can calculate that. And let's say you calculate the area of the bottom and the sides. If you calculate the area of just the surfaces and then add them all together, keep in mind, just the outer surfaces. Inside, who cares? Just the outer surfaces. Calculate the area of each side, add them all together, you have just calculated what's known as the surface area, the area of all just the surfaces. So you could do it that way, or you could use the formula A is equal to 2 multiplied by width times the height plus length times the width plus length times the height. Very, very nice. Now surface area, of course, is not at all limited to just rectangular prisms. No, no, no. What if somebody wanted to find the surface area of quite literally the human body? Well, that's what we're going to explore today. What would be the area of the outer surface of a typical human body? There's a formula for that, and that's what we're going to focus on studying right now. So let's get into it. Let me get rid of that, and let's bring it up. Here we go. Now we'll put this off to the side here. There goes the box. So here we have 2 human bodies all the way at the left. Here's what it says. Here is the first problem. It says, physicians can calculate the body surface area. That's what we're talking about, the surface area of the body surface area, capital S, in square meters of an adult using the formula right here. S is equal to the square root of h times w divided by 3600, or 3600 as it were, where h is the adult's height in centimeters and w is the adult's mass in kilograms. We're going to do part A, and part of part B, it will be up to you to continue and finish part B, which I will start. And I will also do part A. Part A is simply to simplify the formula. Alright, so it's always good to rewrite the formula every single time you need to work with it. So let's do that. So here we go. Part A. We have S is equal to the square root of HW divided by 3600. Alright, now we know how to simplify that quite well, in fact. Yeah, we've actually been working on that a lot. There, let's do it. Remember to use the quotient property of square roots. We know this thing is going to split up the square root of h times w divided by the square root of 3600. So now each have their own square root signs. Now the square root of hw, because those are single variables, we know those cannot simplify any further whatsoever. And if you wanted to, you can get them their own individual square root signs, but no need because they're just going to go right back together. So to save some time, let's just keep them like that. But the square root of 3600, well, the nice thing is, if we know the square root of 36, which we do is 6, we can find the square root of 3600 very easily. You just simply take off the zeros, which we know is 36, and then we know the square root is 6. which means the square root of 3600 is 6 plus only one zero, which is 60. In other words, 60 times 60 is equal to 3600. So, we have just done part A. We have simplified the original formula. Why was that important? Because I think it's better for part B, in which we're going to have to use this formula, to use the simplified version. Remember, using a simplified version of any expression or formula is always going to be beneficial to you because smaller numbers. Instead of using 3600, heck, instead of using the square root of 3600, we only need to use the number 60 in the denominator. And it's going to be easier for us. There's part A. Now, for part B, it reads, does an adult who is 1.7 meters tall and has a mass of 70 kilograms have a greater body surface area than an adult who is 1.5 meters tall and has a mass of 70 kilograms? So please note, they both have the same exact mass, but they're not the same height. The first adult is 1.7 meters tall, while the second adult is 1.5 meters tall. So we're going to see if that has an effect on the body surface area. And if it does, explain what the effect height has on surface area if two people have the same mass. That's exactly the situation here. Two people have the same mass, both 70 kilograms. They have different heights. We're going to calculate their body surface area and see if height makes an effect. You will see the answer is fairly obvious. You might already think that you know, and odds are if you're using logic, you're probably going to be right. But we still got to do the math to prove it. So here we go. Part B. I'm going to make this a little smaller. There we go. All right, so part B. Does an adult who is 1.7 meters tall and has a mass of 70 kilograms have a greater body surface area than an adult who is 1.5 meters tall and has a mass of 70 kilograms? So we have, in fact, two adults, essentially. So it helps to keep it organized. Let's call this person over here adult number 1, and over here we'll do the calculations for adult number 2. Now, before I continue, it will be your duty to calculate all the information for adult number 2. I'm going to calculate the information for adult number 1. And then following my example, you'll calculate adult number 2, and then compare the two body surface areas and come to a conclusion. So, here we go. S is the formula again, is equal to the square root of HW divided by 60. Remember, we are going to use the simplified version just to make it easier on ourselves. Alright, now what we want to do is try to establish some variables here. Well, in this, we have S, we have an H, and we have a W, each representing different things. So let's see, S. Well, if we look back at our worksheet right here, it says S is the body surface area in square meters. Alright, so that we are all on a good page, let's write after that square meters, because we don't know what that is just yet. And then, let's look back here, we have H and W. H is the adult's height in centimeters, and W is the adult's mass in kilograms. Alright, good to know. So let's label that up if we might. H, of course, is in meters, and the weight was in kilograms. Alright, now let's see what information they gave us in the actual problem itself. Here we go. An adult who is 1.7 meters tall and has a mass of 70 kilograms. Now please look at what the formula is saying. It says right here clearly H is the adult's height in centimeters, but they are giving us the adult's height in meters, 1.7 meters. But the formula only calls for centimeters, so it is our duty first to take 1.7 meters and figure out what that is in centimeters, which is actually a very simple calculation, in fact. So let's do that down here where we have our h. What they've given us is h is 1.7 meters. Alright, but we don't want 1.7 meters. We need to figure out how many centimeters that is. Well, let's see here. We know the prefix centi means 1/100th. And if we think about a centimeter, there are 100 little tiny of those centimeters in one large meter. Which means to convert 1.7 meters into centimeters, we have to multiply by 100. In other words, just move the decimal 2 places to the right. It's one of the reasons that the metric system, converting between units in the metric system, is so easy to do. It's because it's just all base 10, which means we're just multiplying by some multiple of 10 to get our new unit. And we all know a faster way to do that is just to move the decimal. So if you multiply 1.7 times 100, you're getting the same response as if you were to move the decimal 2 places to the right. In other words, what I'm getting at is 1.7 meters is equal to 170 centimeters. Very good. Now, if you want to go back and read it, you can, but you'll notice that we've said it a few times. W was 70 kilograms. In fact, the 70 kilograms is going to be consistent throughout both adult 1 and adult 2. So now we have all of information to begin calculating. All right, here we go. Remember, whenever you have a formula, rewrite the whole thing, but then just erase. Is it letting me erase? Wait, no. Anyways, we'll just write it again because it's not letting me erase for some reason. I guess when you're recording, you can't erase. No worries. S is equal to the square root of h times w. Well, h we now know is not 1.7. We're going to use 170 multiplied by weight, which is 70. And then we're going to divide that by 60. So now we have all the information we need. We just need to start calculating. So let's give ourselves a little bit more room here. And here we go. Order of operations is grouping symbols first. And within the grouping symbol, which is the radical sign, we've got 170 times 70, which is 11,900. Feel free to confirm that on your own if you wish. And we're still dividing by 60. Now for this, of course, you are more than welcome to use a calculator. But instead of using the equal sign, let's say it's approximately, because we're going to get a pretty large number, 1.82. 1.82 what? Remember, meters squared, because what we just calculated is a body surface area. So 1.82 is for adult 1. So this is all the work that we needed to do to calculate for adult 1. We know adult 1's body surface area is 1.82 meters squared. Remember, area, if it's surface area or just normal area, the unit is always squared. And that's what we got, 1.82 meters squared. Okay, so I'm done doing my part. Now it is up to you to do your part. You are going to use this 1.82, of course, to help explain if there is a difference. Now going back to the question, we just calculated the first part that says, does an adult who is 1.7 meters tall and has a mass of 70 kilograms, all right, so we just calculated that person, have a greater body surface area than an adult who is 1.5 meters tall and has a mass of 70 kilograms. So now your job is to calculate the second adult, the one who is only 1.5 meters tall. Calculate their body surface area and compare adult 2's body surface area, the one that you just calculated, to the one that I just calculated. And then based on that, I want you to explain what effect height has on surface area if 2 people have the same mass. So you just calculated 2 people that have the same mass, 70 kilograms, and you calculated surface area, body surface area for both of them, compare those 2 numbers, and then answer the question. Does an adult who is 1.7 meters tall and has a mass of 70 kilograms have a greater body surface area than the adult the one that you just calculated? So that's what you're going to do. you are going to calculate adult 2, their body surface area, and then explain what effect height has on the surface area. As you're doing that, please make sure that you are explaining your steps along the way. I don't just want to see calculations on a page. No, no, no. I want to see explanations as to why you are doing what you're doing, okay? You can respond in a few different ways. If you want to just simply type or write out your explanation and your solutions and your final response and submit them to Canvas that way, that's fine. Or you can record yourself on your iPad explaining it. I will be glad to listen to that. Or if you want to, you can make a little video of yourself, kind of like a YouTube thing. You don't have to post it to YouTube, of course, but you know what I'm talking about, a little video of you explaining it. Or if you wanted to, feel free to download an app called EduCreations. It is free, and make your own screencast in response. I'd be happy to accept any of those, okay? So be creative. Heck, if you wanted to, you can even make a Vine of it. It would only be 6 seconds long, and I hope you can get all your work in and your explanations in, but if you can do it, then do it. All right, folks. Hope you enjoyed this. Feel free to email if you have any questions, but once again, here is the problem at hand. Let me make it a little bigger so you can see it. If you have any questions, feel free to email, and I look forward to reading your responses. Have a great day.